So that means we have, let's say if we're solving for angle B, so sine of B over 31 equals sine of A, which is 20.5, over side A, which is 12. Okay, so that means that sine of B, actually if you just multiply both sides by 31, sine of B is equal to 31 times sine of, forgot my degrees, 20.5 degrees divided by 12. Okay, so if you plug that into your calculator, actually let me move that over just a bit, I'll do it up here. No, sine of B is equal to 0.9407. Okay. So to find the actual angle, we apply sine inverse to both sides. So apply sine inverse. Okay, so that means that angle B would equal sine inverse of 0.9407. Which means that B, actually, you hold off there for now, because right now we have our angle B. And what I usually do here is draw a column for our two sides. Yep, and actually I forgot to put something on the other sheet. So if you go back to where it said two solutions, there's something I wanted to put down there. Make sure I did not miss it. Here we go. Okay, so in this case, we're going to solve for B1 and B2. And in this case, B2 is just 180 degrees minus B1. Okay. So that's why I stopped at solving for B. Okay. Because here, if you notice, if this is your B1, if your A is moved over here. And if your B2, if your A is moved over there. Okay, so this is only for your two solutions. Okay, so in this case, we can make this our B1. Okay, so B1 is equal to sine inverse of 0.9407. Okay, which means your B1 will be equal to about 64.8 degrees. Okay. Now remember, your B2 is just equal to 180 degrees minus B1. Okay, so that means your B2 is going to equal 180 degrees minus 64.8 degrees. Okay, so B2 is equal to 115.2 degrees. And that's why I usually put them side to side. So as soon as you get to the B, normally I just stop right there, and you can just separate it right there. Because B1 and B2 are just so closely related. Okay. Now for C1, remember that's 180 degrees minus angle A minus angle B1. Because remember, angle A is exactly the same for both. And to solve for C2, that's going to equal, well, angle C2. Let me put that there. That's going to be 180 degrees minus angle A minus angle B2. So you're going to do the same for both. It's just that your B and C are going to be a little bit different. Okay, so your angle C1 is 180 degrees minus your angle A, so minus 20.5, minus your angle B1, so minus 64.8 degrees. Okay, so your angle C1 is actually going to equal 94.7 degrees. Okay, and your angle C2 is going to be 180 degrees minus angle A, which is still 20.5. Remember, that one doesn't change. Minus your angle B2, which is 115.2 degrees. Okay, so that means your angle C2 is going to equal 44.3 degrees. Okay, so we have all of our angles. They gave us angle A, and we solved for B1 and C1 and B2 and C2. Okay, so all we have to do now is solve for our side C, because we have side A and side B. So we just have to solve for side C. Solve for side C2. Okay, so here we can just use law of sines. So sine of C1 over lowercase c1 equals sine of A over A. Okay, so sine of C1 is sine of 94.7 degrees divided by C1, which is unknown, is equal to sine of A, so that's sine of 20.5 degrees, forgot about that, all over side A, which is 12. Okay. So if we go ahead and cross multiply, our C1 is equal to 12 times sine of 94.7. Uh-oh, clean that up a little bit. Actually, let me slide that over. Looks like I'm running out of room. Times sine of 94.7 degrees divided by sine of 20.5 degrees, which equals 34.15 centimeters. Okay. So for our C2, we can use the same thing, but just sine of C2 over C2. Over side C2 equals sine of A over side A. Okay, so sine of C2, angle C2 is 44.3. So we have sine of 44.3 degrees divided by side C2, which we don't know, so we just leave that as C2, equals sine of A, which is sine of 20.5 degrees, over side A, which is 12. Okay. And again, we just cross multiply. Okay, so we know that our side C2 is equal to 12 times sine of 44.3 degrees divided by 12. Oh, sine of 20.5, sorry about that. Okay, so you plug all that into your calculator and you end up with 23.93 meters. So whenever there's more than one solution, it kind of doubles your work. But it all starts with the A is less than, H is less than A is less than B. All right, so any questions on that one? Or you're just waiting for it all to sink in? All right, so like I said, whenever possible to find out whether or not you have more than one solution, try to figure out what your H is and compare it to your A and B. That's usually a good first step. Okay, so now we're going to look at law of cosine. Oh, you still writing? Okay. And again, I'll add the notes, the proofs to the scanned notes. You don't have to know them, but in case you're interested. Okay. Now, the law of cosines look like they're really long and hard to remember, but I'll kind of point out a pattern to where it'll make it a little easier to remember them. Okay. So a squared is equal to b squared plus c squared minus 2bc cosine of angle A. B squared equals a squared plus c squared minus 2ac cosine of angle B. And c squared is equal to a squared plus b squared minus 2ab cosine of angle C. So you kind of see the pattern. If you're solving for a squared, you'll have everything but a over here. So if you're solving for a squared, you have b squared plus c squared minus 2bc. Then the only a you'd have is your angle A. Same thing with b squared. You'd have everything but b over here. So you have a squared plus c squared minus 2ac. So those two just show up right there. And the only b you have over here is your angle B. Okay. So they all kind of follow that pattern. C squared is just a squared plus b squared minus 2ab. And the only c you have is angle C. And I'll add that to the notes. Okay. All right, so for law of cosines, you can actually solve for a missing side. or angles. If you just have, let's say, either all three sides or all three angles, you can solve for pretty much with anything. Oh, two sides or two sides and an angle. Okay, if you remember the law of sines, you had to have at least two sides and an opposite angle, or two angles and an opposite side. So you couldn't have just all three sides. With law of cosines, you can have all three sides and solve for everything. So it's a little bit different. Law of sines. Oh, clean that up a little bit. Needed two angles and an opposite side, or two sides and an opposite angle. So it's really dependent on what they give you. If they give you three sides, they'll usually tell you use law of cosines to solve this or that, or use law of sines. But if you're only given three sides, then you know that you're going to use the law of cosine. All right, oh, might as well start on a new page. I don't think this is going to fit. Oh, anyone's still writing? All right. Oh, you still writing? Yeah. Oh, I saw your pen move at the last minute. Okay. Didn't want to snatch it up too early. Okay, so let's say, for example, if you have three sides, which is just SSS. Okay, let's say we want to find the three angles. Of the triangle. And let's say we draw out our triangle. And let's say sometimes they'll switch it up. And we'll move the A, B, and C around a little bit. You can always rearrange it if you want to. And let's say this C is equal to 14 feet. Side B is equal to 19 feet. And side A is equal to 8 feet. Clean this up a little bit. Okay, so let's say for the first we'll solve for angle B. You can pick any angle to solve for first. So pick any angle. To solve for first. And I just randomly pick angle B. So to solve for angle B, I'll use the B squared law of cosine. So B squared equals A squared plus C squared minus 2AB, 2AC, sorry about that. times cosine of b. Okay. So we just plug in everything we know. So b squared is 19 squared equals a squared plus c squared minus 2 times a, which is times 8 times c times cosine of b. Okay, so that gives us 361 equal, clean that up some, equals 64 plus 196 minus 224 times cosine of b. Okay. And here we just solve for cosine of b. Okay, we combine our like terms, and once we do that, we subtract, and then we divide, so we're just solving for cosine of b. Okay, so cosine of b is actually equal to negative 0.45089 once you get done dividing and subtracting and everything else. Okay, so now we just apply our cosine inverse to both sides. Okay, so that gives us angle B is equal to cosine inverse of negative 0.45089, which once you plug that into your calculator, angle B is equal to 116.80 degrees. Now, if you wanted to, you can actually plug it in and solve for angle A and angle C. But once you solve for one of the missing angles, you can go right back to law of sines. You only need to use law of cosine one time. And the reason why is because now you have an angle B. You have a side A, B, and C. So once you have two sides in an opposite angle, you can just use law of sines. Okay, so we have sine of B over side B is equal to sine of angle A over side A. Okay, so that means you have sine of B, which is sine of 116.80 degrees, over side B, which is 19, equals sine of A, which we don't know what A is, so we just leave it as sine of A, over side A, which is 8. And we just go ahead and, actually, we just multiply both sides by 8. Okay, so we know that sine of A is equal to 8 times sine of 116.80. Degrees divided by 19. Okay, so we know that sine of A, I'll move this over a little bit, is actually equal to 0.37583 once you plug all that into your calculator. Oh, sorry about that. So if you apply sine inverse to both sides, clean that up some. Okay, so A is going to equal sine inverse of 0.37583. So once you plug that into your calculator, A will equal 22.08 degrees. Okay. And remember, whenever you have two of your angles, you don't have to use law of sine or cosine anymore. We just know that angle C is going to equal 180 degrees minus angle A minus angle B. Since you add all three of them together, you get 180. Okay, so that means angle C will equal 180 degrees minus 22.08 degrees minus 116.8. Which is equal to 41.12 degrees. Clean that up just a hair. All right, so any questions on that one? All right, and just if you were curious, let's say if you were looking for your height, just to compare. Okay, just a little side note. Your h is actually equal to, if you were looking for this angle A, move this up a little bit, to c times sine of A. Because remember, it's opposite over hypotenuse. So in this case, it's opposite over hypotenuse there. So it won't always be B angle sine of A. It'll be depending on where the opposite and hypotenuse is. Okay, which is 14 times sine of 116.80 degrees. So that's actually 12.50. Okay, so your side A is less than your height. Okay, so you only have one solution. And that's what I was saying, like when you draw it this way, it's not going to be graphically correct. It's just something to visualize. All right, so any questions on that one? All right. Still writing. All right. Might as well go ahead and restart it.